So today we're going to have a look at finding the nth term of linear sequences. So to begin with, they could ask or show you a sequence using pictures. So in this question here, we've got pattern 1, which has got 5 dots, pattern 2, which has got 9 dots, and pattern 3, which has got 13 dots. In part A, asks you to draw the pattern number 4. So if we have a look at pattern 2, you can see the orange square is what we started with in pattern 1. So therefore we have added these 4 dots on in pattern 2. Likewise in this pattern 3, started with our original pattern 3, we've added 4 dots on, which is our pattern 2, and then we've added another 4 dots on, which is our pattern 3. And this is why you can see the increase is adding 4 each time. So now to draw pattern number 4, first of all we need to replicate pattern 3. So now I've drawn pattern number 3, we then need to add our 4 extra dots on. And that's going to get us our first mark. The next part of the question then asks you to complete the table. Well, we've already spotted that we're adding 4 dots each time. So we've got 17 in pattern 4. Again, you can double check this by counting the dots in your diagram for part A. And then pattern 5, we would add 4 again to get 21. Looking at part C of the question, it wants you to find an expression in terms of n for the number of counters in pattern number n. So to begin with, we have to work out the difference between our two numbers. So we are adding 4 each time. That is the number which goes in front of the n. Now we write out our 4 times table. We've got 4, 8, 12, 16 and 20. You can see that our 4n sequence, our 4 times table, doesn't match on at the moment. So our first term in our 4n sequence is 4, but we know the first term in our sequence was 5, so this is exactly 1 away. If we have a look at our second term in our 4n sequence, that is 8, and our second term in our sequence is 9, so that's also 1 away. If we have a look at our third term in our 4n sequence, it is 12, whereas in our pictures we had 13 dots. So again, it's 1 away. So here you can see our 4n sequence, add 1, gives us our nth term for our number of counters in pattern number n. So pause the video now if you'd like to have a go at this question by yourself. So to begin with, looking at part A. Again, if we have a look at what we started with in pattern 1, we started with 3 grey tiles and 1 white tile. Then in pattern 2, we've now got 4 grey tiles and 2 white tiles. So what we have added is an extra grey and an extra white tile. In pattern 3, we've got an additional white tile, and now we've gone from 4 to 5 grey tiles. So all we need to do is add an additional grey and white tile onto our pattern number 3. So, part B, it wants you to find the total number of tiles in pattern number 20. There are a few ways to complete this. So we could have a look at how many tiles we've got in total in pattern number 1, which was 4. And then have a look at how many we've got in pattern number 2. Well, we said we've increased it by 1 extra grey and 1 extra white tile, so that would be 6. And in pattern number 3, there's another extra 2 tiles added, so we get 8. So we could just continue this sequence until we get to our 20th number. So we can clearly see from this that we've got 42 tiles in pattern number 20. Another way you could have solved this is by working out the nth term and then substituting in the number 20. So in part C, it wants us to write an expression in terms of n for the number of grey tiles in pattern number n. So we have to be careful here, we are only looking at the grey tiles. So to begin with, we need to write down how many grey tiles we have. So in pattern number 1, we have 3 grey tiles. In pattern number 2, we have 4 grey tiles. And in pattern number 3, we have 5 grey tiles. So now we can work out the nth term of this sequence, 3, 4, 5. First of all, we work out the difference between our terms. We can see it's got a difference of 1. So that is our 1n sequence. Now we can write down our 1 times table. After this, we need to see if our 1n sequence matches on to the number of grey tiles. Well, here we can clearly see our first term in our 1n sequence is 1, and our first term in our tiles sequence is 3. So that's 2 away. If we have a look at our second term, we've gone from 2 to 4. Again, that's 2 away. If we have a look at our third term, again, that's 2 away. So we know it's our 1n sequence plus 2. And that gives you the nth term for the number of grey tiles. Okay, so having a look at question 3. It asks you for the next term in the sequence. So again, we can spot we are adding 4 each time. So therefore our next term would be 21. Now to write down an expression in terms of n for the nth term, we again work out our first difference, which is 4n. We can then write down our 4 times table, and we can see how to match our first term in both sequences. So our first term of 4n is 4, but our first term of our sequence is 5. So that's exactly 1 away. Just double check with your second term that this still works. So to get from 8 to 9, we add 1. So therefore our nth term is 4n plus 1. Okay, pause the video now if you'd like to have a go at this question by yourself. So to begin with, we work out our difference between our terms. Here we can see we're adding 6 each time. So therefore we start with our 6n sequence. This is just our 6 times table. Our next step is to see how our 6n sequence matches on to this sequence in the question. So to go from 6 to 11, we're adding 5. Just double check that with the second one. 12 to 17, we're adding 5. So therefore our sequence must be 6n plus 5. So the final type of question you can get asked in your exam is to show that a number is in the sequence. There are a couple of ways of going about this. You can either continue this sequence by adding 3 each time until you prove or disprove that 34 is in there. That works well for this question because this number is quite low. However, sometimes in the exam it might ask you, is the number 1034 in the sequence? In which case you wouldn't want to have to continue the sequence on. So in this case, if we wanted to find out the number was in the sequence, what we'd need to do is find the nth term of that sequence. So here we're adding 3 each time. So therefore we need to write down our 3n sequence. We've got 3, 6, 9, 12. Our next step is how we match it on to our sequence in the question. Here you can see we're exactly 2 away from each term. So therefore our nth term must be 3n plus 2. So now to show if this number is in the sequence, what we need to do is put our nth term equal to whichever number it states. So 3n plus 2 equals to 34. You now have to solve this equation. So we can solve that by subtracting 2 from each side. That leaves us with 3n is equal to 32. And then finally we need to divide by that 3 to work out what n is. So this equals to 10.6 recurring. If n is not a whole number, so is not an integer, that means it is not in the sequence. So we now know that 34 is not in the sequence as n isn't a whole number. So pause the video now and have a go at this question. So having a look, first of all we need to work out the nth term of the sequence. So here you can see that we're adding 6 each time. So therefore our sequence must be 6n. So we write out our 6 times table. Then if we have a look at our first term of our 6n and compare it to the question's first term, we've gone from 6 to 3. So we've subtracted 3. Just double check this with the second term. To go from 12 to 9, you subtract 3 as well. So therefore our nth term of our sequence must be 6n minus 3. Ben says that 150 is in the sequence. Is Ben right? So again, just like before, we write down our nth term, we put it equal to 150. We now have to solve this equation. So here we're going to first of all add 3 to both sides, and that leaves us with 6n is equal to 153, and then divide both sides by 6 to get what n is equal to. This equals to 25.5. So therefore it is not in the sequence as n is not a whole number. Okay, and because you've shown that working, that is the explanation for your answer.